Hello everyone and welcome to our 6.4 notes on triangle midsegments. Today's warm-up question is, what would be your game plan for a zombie apocalypse? Personally, I would just go to Costco and write it out for as long as I could. So today we are actually going to get into a lesson on triangle midsegments, and we started class by doing an exploration in GeoGebra. And so I can post this link for those of you that were not here that missed it. But we asked some questions and kind of actually discovered all of these ideas on our own. My students noticed that no matter how they moved the triangle around, this angle 36.5 matched the other angle measure, and they discovered all of the theorems that go with triangle midsegments before we even got to the notes. So here are our notes. The first thing I want you to notice is that a triangle midsegment is going to be created by connecting the two midpoints. So a triangle midsegment connects the two midpoints of two sides of a triangle. And so how did we know that these points were midpoints? If you look at point D, it has a congruence mark on either side, which means that it must be in the middle of that segment AB. And the same is true with point E. Point E has two congruence marks indicating that E must be in the middle. And when you connect those two midpoints, that mid-segment is formed. And so we learned a few important things about it whenever we were doing our GeoGebra exploration. The first thing we learned is that it's going to be parallel to the third side. So you can see that those two blue segments are parallel. You can see that those two pink segments are parallel. They're facing the same way and they'll never cross. And then those two yellow segments are parallel and they never cross as well. We also learned that it is half the length of the parallel side. So it's exactly half the amount. And so we had 3 sets of congruent segments created. The blue sets, each of those individual blue sets, so like when I'm saying that, I mean like this one to here, and then this one, all 3 of those would be congruent. And so we could literally just copy that mid-segment twice. If you double its length, you get the third side. So all 3 of those blue pieces are congruent, all 3 of those small pink pieces are congruent, and all 3 of those yellow segments are congruent. And then here was our major takeaway. If you double the mid-segment, you get the third side. So if you double XY, you get PR in blue. If you double XZ, you get QR. And if you double YZ, you get QP, meaning if I were to double this amount, this segment right here, I would get this whole thing. So that is what a mid-segment is. That's the major takeaways from our discovery today. And so then we're just going to work some problems together on doing some triangles and finding missing pieces based on what it's asking for. So the very first thing it wants us to find the measure of angle OUV, but I want to pause here and recognize that this does not work for any kind of segment in a triangle. It only works for a mid-segment. So the first thing I'm going to have y'all do every single time is make sure that I'm either told that it's a mid-segment or acknowledge that it is the segment that's connecting two midpoints. U is a midpoint, V is a midpoint, so I can use these ideas. I can use these theorems. And he wants to know, what is the measure of OUV? So O, it starts at O, goes to U, goes to V. So it's this angle right here that I'm looking for. And remember from our GeoGebra exploration that no matter how I dragged those around, those were going to be congruent. So yes, I can fill in 65, but I want to make sure that we know why. Why am I able to say that those are congruent? Well, remember we just said that these lines are parallel. And if these lines are parallel, and if this is my transversal, then those angles, this is in the corner, and then this is in the bottom right corner, those are corresponding angles. And we know from a previous unit that those angles must be congruent. So the corresponding angles theorem tells me that if those lines are parallel, then those angles must be congruent. So this would also be 65 degrees. Okay, so why can I find NUV, which is right here, starting at N, going to U, then going to V? I can look at this in one of 2 ways. I can look at this and say, hey, these are same side interior angles, so those must add up to 180. So I could say that this is going to be 115 degrees because of same side interior angles. Or I could also say, if you look at this overall, this is making a straight line with that yellow angle, and so those could also be the linear pair postulate. Okay, so we can find missing angles based on mid-segments because of the parallel lines. All right, this next problem starts by saying that T, U, and B are midpoints. That is actually necessary because it does not have the congruence marks like it normally would. So I'm going to go ahead and add these midpoints, which means that these segments are going to be exactly half. B is the midpoint as well, so I can color code this up moving forward. So how do I find Q to U? How do I find Q to U? Well, Q to U is just going to face the exact same way as T to B. That's the side parallel to. And so I can look at that missing piece, and so that would have to be 30. All right. also be 30 for Q to U. Okay, how do I find Q to R, which is this whole thing? It would be 30 plus 30, which would then be 60. So that whole thing would be 60. It's two of those midsegments put together. You double the midsegment to get the third side. Okay, so let's switch colors. How do I find S to T, which is just this little piece? Well, that whole thing is 50, and so half of that is just going to be 25. Okay, and then how do I find U to T, which is this piece right here? That faces the same way as the 40, which is the whole amount. That's that third side. That means that UT must be 20. All right, it then wants us to find U to B, which is facing the same way as the 50. So I know that it's going to be half of that since that's the midsegment. And then it wants us to find, last but not least, it wants us to find B to R. B to R goes from here to here. That is half of the whole thing, which is 40, which is 20. So I can find all of these missing pieces simply from the fact that it told me that those were midpoints. If it didn't tell me that, I would not have been able to solve for any of those missing pieces. All right, number 3. Number 3 is asking us for two things. It's asking us for missing sides and for missing angles. And so the first thing I notice is that it does have the necessary marks. E is a midpoint, D is a midpoint, and F is a midpoint because it shows those congruence marks on either side that are congruent. And so because of that, I'm able to find these missing pieces. So how do I find B to A? B to A is parallel to F to D, which is 7. So that whole thing would be 7 plus 7, which makes 14. How do I find, I'll switch colors here. How do I find D to C? D to C is parallel to E to F, which is 8. And so that small piece must also be 8. Those are congruent segments. So they have the same length. How do I find E to D? So I'm going to switch colors again. You'll know I'm all about color coding. E to D is parallel to the piece that has a length of 20. And so that mid-segment is going to be exactly half. That's going to be 10. How do I find the measure of angle BFE? So I'm going to highlight that. I'm going to change colors. BFE is right here. We'll look and see what other angles are given on the picture. This angle is also 44 degrees. So that is, my answer is going to be 44 degrees as well. If you had to provide a reason, you would just say because those are corresponding angles. And then how would you find EFC, which is this full amount, EFC? That is going to be supplementary. It makes a linear pair with 144, which is going to be 136 degrees. So that star angle is 136 degrees. So we found missing sides and missing angles. So I want you to try this problem on your own. Try to find the missing pieces if you're watching this video, and then click play to see how you do. So again, I have the proper marks. I know that E is a midpoint. I know that D is a midpoint and F is a midpoint. And so all of these are midsegments. So how do I find D to C? D to C is just going to be half of that third side. That third side is 57. So we're going to do 57 divided by 2. So that would give me a length of 28.5. We take 57 and divide it by 2. So both of these sides would be 28.5. So D to F. DF is here. It is parallel to the 60, so it's going to be exactly half, which is 30. And then BC, I kind of change it up on us. The BC is this full amount. So how do I find, well, hold on, let me see, make sure I'm highlighting the right one. How do I find B to C? B to C is from here to here. It is going to be double this mid-segment, which is 22.5. 22.5 times 2 is 45. Then it asked me for some angles again. How do I find the measure of angle AED, which is this angle right here? I noticed that I see a 64 degree angle here. So what is the relationship between those? Those are alternate interior, and so those angles will be congruent. That will also be 64 degrees since those two blue lines are parallel. And then last one, it wants us to find the measure of angle DFB. DFB goes from here to here to here. So DFB is going to be that full amount. It is going to be supplementary to the 64 degree angle, which is going to be 116 degrees. That is the obtuse angle. Those are not the same size. Those are different sizes. When they're different sizes like that around parallel lines, they're going to be supplementary. When they're the same size, they're going to be congruent to each other. All right, here is what you might see using some algebra. I noticed that I do have this mid-segment right here because it's a midpoint connecting a midpoint. And the formula that we discovered earlier was that 2 times your mid-segment is going to be equal to your side, your third side. that third side. And so what I need to do is I need to make sure that I'm doubling the correct thing. If you double the small piece, you're going to get the big piece. We know that if we doubled the big piece, that would never be equal to the small piece. So we're going to double our mid-segment, and that's going to be equal to our third side. I like to put it in parentheses. You'll see why on the next problem, but it just reminds me I'm doubling that whole thing. So if I double 3x, I get 30. And so that'd be 6x equals 30. X equals 5. We always check ourselves before we wreck ourselves in my class, which just means go back and plug it in and make sure that that actually makes mathematical sense. So if I plug this in, that would give me a side length of 15 for this mid-segment, and then 30 for the third side, which is exactly half. Okay, again, why do I like to put the parentheses? Because sometimes you're going to have an expression that you're going to have to distribute to. So 2 times 4x minus 1 equals 6x plus 24. How did I know to double the 4x minus 1 and not the 6x plus 24? That is because that is our mid-segment. If we double that smaller piece, we're going to get our longer third side. And so this is where your teachers used to do these little arrows, and they're like, oh, don't forget, distribute and pass out the 2 to everything in that group. So that's going to be 8x minus 2 equals 6x plus 24. We'll get our x's on the same side. We'll get our constants on the same side, and so x is going to be a value of 13. But again, check yourself before you wreck yourself. Go through and plug that in and make sure that you actually get what you expected. So this would give me a side length of 51 when I plug in x equals 13. And then 6 times 13, and then you do plus 24 is 102. And so that does check out. 51 is half of 102, and 102 is double 51. All right. We're going to skip this one because this is just like a few of the other ones we just did. So we're going to move on to number 8. Number 8 starts by telling me that these points are midpoints. And so because these are midpoints, sorry, that was my dog. Because these are midpoints, I'm able to find missing values in this triangle. And so all of these are midpoints, which means that all of these are mid-segments. So I'm going to highlight the parallel sides because it helps me see who goes with who. All right, and then last but not least, we've got this piece, and here we go. So let's fill in the missing pieces that they give us. They tell us that M to P is 17, so I'm just going to write that directly on the segment. It tells me that L to K, this big piece, is 24. And then it tells me that P to N is 13, so I'm just going to write that directly on the segment. So I'm going to actually go ahead and fill in all of the missing pieces on this problem. If this is 24, the mid-segment is going to be half of that, which is 12. If this is 13, the third side is going to be double that, which is 26. And then if this piece is 17, then that full amount must be double, which is 34. So what is J to K? J to K is 34. J to L is 26. We've already found it. M to N is going to be 12. And now it wants me to go find the perimeter of JKL. That is where you add. Perimeter is where I always think where it says SpongeBob SquarePants says bring it around town. It just means add all the outside pieces together. So 26 plus 24 plus 34. 84 is my answer to that. Why is that significant? Ooh, let me change to a pen. Why is that significant? That is because that is the full perimeter. If I wanted to find the perimeter of just the inside triangle, think about it. It should have a relationship to the perimeter of the outside triangle. So the perimeter of triangle MNP, if I did this correctly, should be exactly half of 84. And so that should be 42. But add those numbers together and see if you did it right. 12 plus 13 plus 17. 42. And so I know that I have solved this problem correctly using the idea of the midpoint theorem.